Hello guys, welcome back. In this video, we will take a look at the time series analysis part 2. So first of all, you want to log into the Brightspace and then download this AAPL Apple Stock CSV file first. So first of all, you download that. And then you open the RStudio. First of all, let's get R Markdown files. So let's go to New File, R Markdown. And then we're going to type in time series analysis part 2. And I'm going to save it as a Word file. Click on OK. Now I'm going to suppress the console. And then I'm going to delete all these unnecessary lines first. And then after that, go to File, Import Dataset, and then click on From Text Base. Click on that, and go to Download. And I'm going to import this AAPL CSV file. Okay. And this is basically the Apple stock price from April 4th, 2025, all the way down to April 3rd, 2023. Okay. So that's imported, right? Make sure that the name here stays as AAPL and click on import. And you'll see this. So we have the first column is date, second one is opening stock price, and then high, low also has a volume, right? So we have a close, adjusted close, and then volume. Okay, so that's all the basically all the columns in the time series data set. I'm gonna suppress this for a second, and then first of all, I'm gonna install a couple packages like part 1. Get a So first of all, let's load the Elasticsearch package. Also, I think we need to copy this code from this console. Okay, and then I'm gonna paste it under the R block. Okay, that's one thing we're gonna do, and then also we're gonna do couple packages: library, forecast package, and also library of T series. And then close coding block. Let's run the code. And the output looks good. Close that. Now, our next thing we'll take a look at the graph of the Apple stock price. So let's plot the time series data set. Of the Apple stock. Get a coding block, curly wave, and then we're just gonna focus on AAPL and $. We just focus on the closing price. Right? So that's our main focus, because time series data sets will only have 2 columns: time in the index form, and also the closing price. And then let's plot it. Plot AAPL. YLab is Apple stock price. Main is Apple stock price. From April 3rd, 2025 to April 3rd, actually it's April 4th, April 4th, 2025, all the way to April 3rd, 2024. And then also we're going to run an ACF test. ACF is auto-correlation analysis. Now take a look at whether the stock price has a relationship with the lags of itself, meaning if the previous stock price has any impact on the current stock price. So let's see how that goes. Close the coding block. Let's run the code. And we get two outputs. First one is it just got a plot here. Look like over the 20 years period of time, that's a pretty clear upward trend. So that means this Apple stock price data set is not a stationary data set. There's no constant mean and variance presented in this data set. And also let's look at ACF graph. Based on the ACF graph, looks like all these lies outside of the 95% confidence. So that means there is no Apple stock has a strong correlation with itself. Right? So that's what this means. Also, if you look at this ACF graph, it shows a very slow gradual decline. So that indicates the time series is very likely not stationary. Now let's clear these outputs and now let's run the ADF test. Run the ADF test. The full name for ADF test is augmented Dickey-Fuller augmented Dickey-Fuller test. To check the stationarity, to verify the stationarity of the time series data set. Now let's run the code, the coding block, and let's do ADF test. APL, let's see what happened. Let's close the coding block, run a test, and this is the output. So we're going to create this what we call AAPL model. Yeah, so using the auto ARIMA mechanism, so based on the data set AAPL information criteria AIC, trace is true. Now here we're going to look at residuals of based on AAPL model, based on our ARIMA model. So basically we come up with these outputs. First of all, the best model is ARIMA 0,10 with the drift. So that's what we're going to go by. Right? This is basically give us the smallest AIC values. Now, if you look at the second graph, this is the residuals AAPL. We also take a look at residuals. Look like residuals has no autocorrelation. That's basically what we see from the residual plot. ACF test, according to ACF test. So we just run the ACF test on the residuals of AAPL model. I'm going to clear the outputs, and also we're going to take a look at let's analyze the partial autocorrelation function. So we get a coding block, open curly wave, and then we'll call this PACF, partial autocorrelation function, ATS AAPL model, $sign residuals. Let's close parentheses, close, and then close the coding block, run the code. So basically, we don't see very clear pattern here on the partial autocorrelation functions here. So we need to do some other analysis. And next thing, let's check the box test. So let's check the box test to ensure no autocorrelation. So first one, let's open the coding block, and then we're going to do the AAPL forecast using the forecast command. AAPL model, based on AAPL model, level equal to 95%, 95% confidence. And each projection is 1 times 52 weeks. They are projecting 52 weeks of next year, which is 2025. Then we do the box test. AAPL forecast, $sign residual lag equal to 5 first. We can check a couple of them. Type this test called June box. Also, we're going to check the 15 lags. You can check basically any lags you like. You want to see previous 15, stock price, right? Whether or not they have impact on the current stock price. And then let's close the coding block. Let's run the code. And then note the null hypothesis HO for the June box test is the data set. Is updated values independently distributed, which means autocorrelation. For the chosen flags are zero, all zero. Okay, so meaning there is no autocorrelation. Okay. And then H1, the data values are not independently distributed. So that means autocorrelation for the chosen legs are not zero. Autocorrelation and let's take a look at the output. For the 5 legs, when we choose the 5 legs, the p-value is 0.3478, which is larger than alpha, 0.05. So we failed to reject HO. That means autocorrelation for all the chosen, all the first 5 legs are all zeros. And then for 15 legs, when we choose the 15 legs, we see that the p-value is extremely small, so we got to reject HO, meaning we accept H1, the data values are not independently distributed, meaning autocorrelation for the chosen for the first 15 legs are not zero. Okay. Not all zero. Okay. Not all zero. Yeah, so that's basically how we interpret the June-Box test. Next, let's take a look at the QQ plot, which is normal contact plot. So check the normal QQ plot. Or contact plot for the residuals. For the residuals, get a coding block. Let's do QQ norm open parentheses AAPL model $ residuals. And also we do QQ line AAPL model $ residuals. Let's check the normality of the residuals. And when we check the residual plot, it looks like residuals present a long tail distribution, which is not a typical sign of normal distribution. So that means this residuals violates a normal assumption. So note the residuals here violate the normal assumption, meaning the residuals are not normally distributed. Now let's use the Shapiro Wilk test to double check. And let's get a coding block and then do Shapiro test. Now we base on the AAPL model, $ residuals. Close parentheses, and then close the coding block. Let's run the code. For the so rejected. Now how about this? Residuals are not normally distributed. Okay, that's our conclusion from the Shapiro test. Next thing we will let us code the AAPL time series data using let's code AAPL time series data set using 52 weeks each year. Get a coding block and AAPL TS. Right. TS indicates it's a time series data set TS time series AAPL. So I put in the starting time start 2005.25. So it's about 3 months into the year, and a frequency equal to 52. And then we're going to plot AAPL TS type 1 YLab. It's Apple stock price mean Apple stock price from April 4th, 2005 to April 3rd, 2024. And let's close the coding block. Let's take a look at the graph right now. Now, if you look at the time series graph here, it's in the times in the index form. You see the stock price, and then we see this overall trend. Definitely there's a trend component. That's upward trend. So, and then we need to take care of that in a second. To get rid of the trend component. So typically, in order to get rid of the trend component, we take the log of the original stock price, and then log difference, right? Take the log first, and then find the difference. And then after that, we can run analysis. So let's clear the outputs, and then let's take a look at the log return, right? So next thing, let's get rid of the trend component. Let's get rid of the trend component in the time series data set. So let's do this. So get a coding block, curly wave. So the typical way how we handle this AAPL DF, we're going to call this AAPL DF. So DIFF, difference of the log AAPL TS, right? So take log first and then find the difference of two consecutive log of the stock price. That's first move, and the second thing we call this AAPL DF1. AAPL DF minus the mean. Okay. So in this case, we will try to be sure, right, the trend component is successfully removed by using the AAPL log difference minus the mean of the log difference. And then let's plot it. AAPL TF1. Now we should see a stationary time series data set. Type is L. XLab is the time. Index time, if you want to put that, it's okay. And then main is Apple stock price, Apple log return. And let's close coding block. It's running. Now, as you can see, now this time series data set becomes stationary, right? And stationary time series data set. And also, let's check the ACF. That's ACF function here, right? Let's quickly check ACF function, ACF plot of the log returns. Okay. Let's see what happened there. So let's run the code ACF APLDF1. Main is ACF of log returns. Let's run the code. And if you observe this ACF plot, looks like we see the log returns are uncorrelated. There's no autocorrelation, right, for the log returns, because almost all of them are located within a confidence interval. So a quick note. From the ACF plot, that we see the log returns are uncorrelated. Since they're all located within the confidence interval, 95% confidence interval. Now next, let's take a look at cyclical components, right? Let's create the unsmooth cyclical component graph, and then smooth cyclical graph. Then get a coding block. And using this code called spectrum cycle, basically, NPL VF1. Main title is unsmooth cyclical graph. And then also we take a look at smooth. Call it smooth R, and then again we do a spectrum. We look at the cyclical component here, APL.df/_df1 spans C30, 30. That's a standard setting, and we call this smooth cyclical graph. Let's check how that goes. First of all, look at this unsmooth cyclical graph. Yeah, it's again, it's pretty. I think we see a lot of like clear pattern here. A lot of cycle, right? It's so, but it's not it's not kind of like consistent cycles here. But if you look into the smooth cyclical graph, we see a much clearer, cycles here. We see this main big cycle here. There's a small cycle, and then all over the place. Okay. There's no clear trend here, so as you can see, there's no clear trend here. So let's decompose the returns to investigate. Let's get a decomposed graph. So we do this DE represent decomposed APL DF1, and start time is 2005.25, frequency is 52. Yeah, I forget to put a TS here in front of it. Yeah, TS in front of the APL DF1 and close parentheses. Now, one more time, let's plot this decomposed graph. And then we will take a look at the outputs, the graph in a second. And once we do this decomposition of the time series data set of the APL underscore DF1, now you can see we see a much clearer, overall trend component, cyclical component, and also there's some kind of like irregular component we can see, and then there's some random noise, right? On the first graph, that's random noise. There's some random movement in the time series graph. So this is the way to get a better, cyclical component here. And then eventually we're just going to run it, create a forecast, right? Create a forecast of APL stock price. We call this, we already called APL forecast. Now we're going to plot it, right? So one more time, create wave APL forecast and APL model 95% confidence 5, and we project 52 weeks into in 1 year, 52 weeks in the following year. Let's run the code and also put in APL forecast, and also let's plot the APL forecast. Yeah, let's see how that looks like. So in the first output, we see all this forecasted stock price in the next week, with the 95% confidence right next to it. Okay. So yeah. Then the second graph basically is just graphical ways of showing how the stock price look like. The shadow region indicates 95% confidence, and this blue line here indicates the projected stock price. Okay. And that's pretty much it for the second part of time series analysis.